Welcome back, everybody, to another Taproot podcast episode. Joining with me today is Ken Reed, and Ken, there was an interesting article put out by Justin looking at is equipment as reliable as it used to be.
Mm-hmm.
I've heard the phrase, we just don't make things like we used to anymore.
Right.
Have you heard that phrase before?
I have. That's pretty common. It seems like everything is just not working like it used to. Things
were
were better back then.
And I can think of examples that I've seen from my work of times when, whether it's vehicles that don't last as long or it's things that just don't feel the same as when you grab something that was an old. Yeah. Like my dad had a shovel that was passed down to him from his dad.
Yeah.
And it's like solid. This thing's old. It's ancient now. I would joke at him if he was in here about it, but it's an old shovel. But that thing holds up and it digs fine. There's nothing. It's not going to break tomorrow. That thing's going to hold up. So there's something that feels different about reliability today and equipment today. What are some things that stand out to you of why things feel different?
Well, I think there's a couple of things that come to my mind. First of all, that shovel's a great example. Materials have changed. So just something as simple as changing the materials. It used to be big, heavy, cast iron this and that, and big chunks of stuff, right? And it felt solid when you held these things. Now things are lighter. And I don't want to use the word cheaper, but lighter. Thinner materials, they just don't feel the same, and it gives you the impression that they're just not as good. That was big, solid cast iron table saws. Boy, I tell you what, those were solid, and now they put aluminum tops on these things. They're not going to last as well because they're lighter. That may or may not be true, but that's what can give you that kind of impression that something is more or less reliable than it used to be. I also think about an example of that. Some of it is we have actually, I think a lot of people probably in our audience has seen this also. Some things aren't as reliable, and because from your experience. So, my dad's washing machine, he still has the same washing machine. My mom and dad, the thing has to be 30 years old. It's the same one, and that thing lasted forever. And I know I've replaced mine twice, maybe 3 times in that time frame because it dies. It just doesn't last as well. So some things like consumer type equipment, some of that stuff, I really feel sometimes isn't as reliable as it used to be. So.
Yeah, I know there's a term they call planned obsolescence, and I remember the first time I heard this, and I don't know how true the light bulb cartel story is.
I've heard that too. Yeah.
I don't know how true it is, but the story goes that, when they were, Edison made the light bulb, but, or perfected the light bulb at a time, and when they were building these, people weren't coming back and buying them enough because they were lasting too long. So they started to reduce the design so that the life of those light bulbs would be shorter.
Right.
Now, I don't know if it's that they were intentionally going, we've got to have a light bulb that lasts a few months and then has to be replaced. What I really think the true fact is that when you're going through this design process, reliability is not the only concern. Manufacturability of materials, the types of materials, the cost of materials. Mm-hmm. So, do I want to pay for a $40 light bulb or a $4 light bulb?
Right. That $40 one will probably last you quite a while.
It might.
But is that really what we want to do?
Yeah,
do we want to buy $40 light bulbs?
And I remember when LED bulbs were becoming the thing, they used to last like 10 years. Mm-hmm. Now they don't. Mm-hmm. I've had LED light bulbs I change now yearly, which to me blows my mind, but it's a thing. You're like, these should last forever.
Right.
So I think some concern is some of, I think, important pieces of equipment, have they gone through that reduction in maybe quality or materials or manufacturability to reduce costs? Has that created a problem for our industry? When
you first build a piece of equipment, you probably overbuild it because you don't know if it's going to work right. So it's they call it a battleship. It's built with extra materials in it, extra thickness in the wall, thickness of the piping. Because we don't know. We don't know what it's going to do. So let's just over design it. And once you start seeing how it's working, then you go into that manufacturer piece and say, you know what, I didn't need a 3/8 inch piece of steel here. I can go with a 1/4 inch piece of steel, and we'll be fine. It'll be okay. And while it's not as quite as reliable, it's reliable enough. So it all fits into that. Yeah.
Yeah, and I think about that from when you've got to look at designing, or you've got to look at manufacturing. You got to have all three components coming in. You got to have the design people understanding what's the goal. Mm-hmm. You've got to have the operations people knowing how we're going to do it, and then there's the maintenance side of it, of how we're going to take care of it so that it keeps functioning in the long haul.
Right.
I think about Elon Musk has a good story where he's talking about with the Model 3. You know, that was a very difficult time for the company and for him. He was sleeping in the factory, right? Mm-hmm. But one of the cells that they were having this big problem with, there was this blanket. I can't remember what the type of thing, but it was a blanket type style thing that goes over the battery, or on top of the battery, and they were like, well, why? This was causing them problems. It was slowing down the line. They're like, why do we have this? Mm-hmm. And well, the operations guys just said, well, safety said we had to have it. And safety, they went and talked to safety. Safety's like, we don't know why we have that. It's not our requirement. They went to this person. They looked around and said, oh, there's no reason to have this.
Nobody could explain why
it was probably somewhere in the design. They originally thought they needed to have it, and they did something else that
negated it.
Yeah, made it not needed, mm-hmm. but it never got removed until operations said, this is slowing us down 3 seconds or 2 seconds or half a second. I don't know what it was, but some amount of time. And they went back to the criteria. And so sometimes in designs, there's things that are missed, and a lot of big machinery is really custom.
Right.
It's really custom. I remember in the facility I worked at, we were over 50-year-old facility, and we had stuff moved in there that was even older than that. Mm-hmm. So we had a couple machines that had been running for over 50 years, and they worked. Now, they weren't pretty.
They probably weren't efficient. They probably used a lot of power compared to the newer stuff.
Probably. Mm-hmm. But they worked, and they did the job that they were supposed to, and they were very simple.
Right.
Like, they were simple to fix. Then we had equipment that we had purchased in the 80s as a business, and it worked really well. It was big. The thing, was functional, but it also had been updated over the years to have modern and better things, mm-hmm. and it worked. And we had new stuff that was really brand new, but I'll tell you, the maintenance guys spent a lot more time on the new stuff than the old stuff. Now, right. Is that because things were simpler mm-hmm. and more efficient? So you and I were talking about this, and we said, old vehicles. You have...
Right, that's a 68 Mustang,
68 Mustang.
There is not a lot of electronics on that 68 Mustang, right? There's pretty much nothing. It's got a distributor and points, and there's no electronics on that thing. So in the big scheme of things, it's relatively reliable. I mean, there's nothing really to break on it as much compared to some of the newer vehicles. But boy, I tell you what, I'm out there tweaking on that thing all the time, trying to get the timing right and get the get everything set. Idle adjustment, idle's off. I go clean the carburetor every now and then. It's those things that, if you ask somebody when's the last time they had to adjust the timing on a modern vehicle, it doesn't happen. There's no such thing anymore because the modern electronics take care of all that for you. So there's a balance there between who wants to go out there and fiddle with your car every 3 months to make sure it stays reliable, as opposed to who wants to have 500,000 new parts that can fail, like in our modern vehicles. And what does that do to reliability? And it's not a straight answer to that. It's not obvious what the right answer is to that.
So I remember in when I was in college, I had my first reliability course for my engineering degree. And in that course, they showed us all these graphs. Mm. And it was looking at the types of inspections and when things would fail. So you had things that were like wear down over time, right? Mm-hmm. What's the failure rate? Well, it's a graph that just basically the failure rate increases over time because as it wears out, it's more likely to fail.
Yep.
But then you had things like electronic components, and they weren't a straight line graph. Mm. In fact, a lot of them were closer to a U shape.
Yeah, it's a Weibull curve, right? On those things, right? Yeah.
And so it might automatically fail. It may not work at all
That's
at the beginning.
That infant mortality is there, where it's just is going to be broken right off the front, or it's going to fail right away.
And then, but if it works, it works, and it stays working for a good long time, and then
until it breaks.
Right. And so it was like you have this kind of wear out failure. You have more of a random failure model, and I think when we think about the types of equipment that we're purchasing, the types of things we're putting in place, a lot more electronics means a lot more introduction to random failures.
Right.
And so it may not be that it's necessarily less reliable or not. It just may be that the type of reliability that you expect from that equipment is different.
Right.
And we don't always recognize that when we're purchasing or
we expect, you bought an older vehicle and the thing would last until it started wearing out and breaking at 150,000 miles. It would start dying because all the parts weren't electronic and they didn't have these random failures built in. But now you've got all this electronics, and now you should almost, thinking on it, you should almost expect random small failures continuously throughout its lifetime because there's more parts to break. But they don't fail on a wear out; they fail on random time. So the types of you're right. The type of failure isn't a wear out failure anymore. It's small random failures throughout the lifetime now. Yeah. Which can be frustrating when you have a vehicle, as an example, that now this doesn't work. My remote start doesn't work now. My cruise control isn't working properly now. All due to small minor failures as it works its way through the system. Yeah.
Now I had when I was in bearing manufacturing, and one of the clients that we had was an automotive client. And when you work as a supplier to automotive, you are always going to be under cost pressure, a yearly cost pressure to reduce cost every year.
Sure.
You're going to be obviously under, shipment, being on time. Those things are extremely important to any automotive supplier. But one of the things that was interesting was a quality change. So our company was an old bearing company. It had been known for quality over that period of time. And it was known for a certain level of quality. It was a premium product, right? So they were selling a premium bearing. Well, the automotive manufacturers, they were slowly paying for not a poorer quality necessarily, like, you want the part to work the same way,
sure,
but the reliability requirements. They didn't need a bearing that was going to last longer than the vehicle.
Right. 500,000 mile bearing isn't very useful in most vehicles anymore.
Yeah, right? we didn't need a wheel bearing that was going to outlast the everything else on it.
Yeah.
And so those design pressures, again, they're driven by cost, they're driven by, maybe the market need.
Right.
Can change the reliability. So I think a good thing is to think about what kinds of things for the people, I think more on the maintenance side, what do they need to think about when looking at the differences between new and old? Yeah,
it's as you're saying, it's a balance. There's no 100% right answer, and sometimes you have to decide where do you want to apply your resources when you purchase a piece of equipment. So looking at some of that 50-year-old stuff that you bought, if you put a pie chart up there that shows where the lifetime costs of that piece of equipment are going to be, obviously there's an initial investment to buy it, but now you have maintenance is in there. You also have efficiency, and if you look at most, like I'm going to use pumps because they're fairly standard and common. Most of your lifetime costs of a centrifugal pump is not in maintenance or initial purchase. It is in electrical power that you're driving that pump with. So does it matter if I'm going to spend a little more on the initial pump, 10% more on the pump, but I gain in 10% in electrical efficiency? I might have just cut my lifetime cost of that pump by a third because I'm not using so much electrical power. But now that pump may have slightly lower reliability. So now I got to add my maintenance costs back into that. So it's really a lifetime cycle cost that you need to look at when you're deciding on what am I paying for and how critical is this piece of equipment. If it's a critical pump, then I don't care how much it electrical power it's using, it's got to work. Whereas if I have 3 backups to this thing and I can turn any one of these 3 pumps on, well, now it's probably electrical efficiency is my more, at the top of my list of things that I'm purchasing this piece of equipment for. So reliability is not standing there all by itself as the thing that you're purchasing for. It's a life cycle cost that you got to put in, but that cost also has to look into the quality of your product. How many times is my customer going to get mad because my plant's down and I can't supply the product to them? All of these things all have to fit into that life cycle cost. And while reliability is a piece of that, people shouldn't be considering that to be the piece of data that's going to make the determination in every situation.
Yeah, I think people look at, cost and they think, at least from equipment standpoint, buy the good equipment or the bad equipment, right? They just think it's black and white. Expensive is good and cheap is bad.
Right.
But like you're saying, a lot of the costs of equipment you don't think about. If it requires lube, does it require expensive or cheaper lube?
Yeah.
Like those kind of things make a difference.
Yeah.
In that lifetime cost. So I think people want to measure. They want to look at how critical is this asset.
Yep.
How much maintenance it's going to require, or repair, or reliability work it's going to require. You might have to do extra testing on some types, right?
Extra monitoring.
Extra monitoring.
Noise monitoring or whatever you've got.
Comes with noise monitoring or doesn't have noise monitoring. Right? There's a lot of those things in there.
Yeah.
So it's like, how critical is this? Does this, what does this require from us? And then also, obviously, things like installation, build quality, brands, things like that all matter. Mm-hmm. What I found really interesting, again, jumping back to my college days, one of the projects that we did for a senior project, I was in material science, so we did weird senior projects. But we looked at different purchased material products, so saw blades, wrenches, hammers, a lot of different types of just things you could buy in a hardware store.
Sure.
At cheap and expensive. We always had a cheap thing and an expensive thing.
Right.
And we did a cost comparison to see what it was made out of, what it said it was made out of, what was those materials and how they would affect life cycle. And what we found was there's a huge difference in the material for the cheap and expensive. Mm-hmm. Now, you can extrapolate that to just about anything you purchase, expensive or cheap. But one of the things that was interesting out of it, and I always take away with me, was there are pieces of equipment that I didn't care if it was the best quality materials.
That's right.
I think about this from like a homeowner standpoint, right? A socket set. I mean, I like a nice socket set.
Sure. But
I don't need an expensive one.
I'm trying to remember the last time I actually ruined a socket set on a piece of equipment, and some of that's because I got decent socket sets. But I'll tell you, my other garage, I have a really cheap set out there that I just inherited. Yeah. I still haven't broken any of those, so they still work.
And so it's like, if I was going to use this every single day 1,000 times, I might want to pay for that expensive.
That's right.
But the average person's not going to use that, and so there was materials that I would, that kind of tooling. But then there was other ones like, I remember mine was circular saw blades, and we were looking at carbide tip circular saw blades. Mm-hmm. And the difference between the cheap and the expensive was scary to me.
Yeah.
Because the things it said it was, is it's like, it's a carbide tip to this type of saw. And no, it wasn't. It wasn't. What they said was not what it actually was.
Yep.
And the quality was really poor.
Right.
And so those kind of things, matter.
Yeah.
And I think understanding the purpose and the quality that you need is a tricky balance.
It is. Yeah, it's easy to wax nostalgic and say, all the old stuff used to work better than it does now. And again, there's some perception there, and some of it doesn't matter if it works better back then. It's if just because it ran better doesn't necessarily mean it gave you the same quality product at the output. and sometimes you just got to pay differently and have different maintenance, and there's just a lot to consider. It's not as black and white as old stuff worked better, new stuff doesn't.
Did you ever see that? Did you ever see that video of a new car being crashed into an old classic car?
Yeah. Yeah.
And the new car just looked like it was destroyed, and the classic car looked like it didn't get dented that much.
Until you looked at that passenger.
That was the thing. And so, again, that's where that safety design comes in. And sometimes they may not be built the same level of strength, but their intention behind what was built
right. Yep.
can be so much better. Again, that crumple zone, all those, the way things deploy in there. Versus a lap seatbelt in your dad's arm.
It may sound good. That look at that, that 56 Chevy. Look how well that stood up, but I don't really care how the vehicle stood up. I'd like to know how the passengers stood up. And there's again, you got to figure out what you care about in there. What are you comparing? That the 56, the vehicle looks much better after the crash, but how useful is that when the passengers are seriously injured?
The car can drive away, but you can't. That's a problem.
That's an issue.
So, I think when we look at new things versus old things, people again they want to jump at. It just doesn't work the same. Mm-hmm. Do you think that there is different stresses that new equipment are going through compared to old equipment?
Yeah, I think that's a good point too. You look at how equipment is being used now, and I'm getting away from consumer stuff a little bit. Let's more towards industrial applications. There are much finer tolerances now on pieces of equipment and the product that you're producing now than there used to be. So when we say this equipment is not as reliable, well, it's no longer making this widget to 1/1000th of an inch anymore, so it's not as reliable. Yeah, but 40 years ago, it was 1/10 of an inch. We didn't care, right? And now the reliability is being measured against the quality of the higher precision pieces of equipment. So that's a piece of it. We're subjecting our equipment. You look at the drilling industry. We're subjecting our equipment to things that was unimaginable 40 years ago. And on some of these deep water drilling rigs and horizontal drilling, these aren't things that our stuff ever had to do in the past. So the environment that our equipment is operating in is different. We're putting stuff up into space now we didn't used to do. So completely different environments that we're putting our equipment through. And it's progressing much quicker now. So that whole part where you had mentioned here about building that battleship stuff and then refining it as you move along, we haven't gotten to the point where we're refining some of this stuff yet because it's brand new equipment and technology is progressing so quickly. You don't get to the refinement piece as fast. Yeah. So the lower reliability stuff is there for because we haven't refined it and because it's in these weird environments that we're putting them in now. So.
Yeah, I think of just the difference in the two types of the newer stuff that we had versus the old from a measurement standpoint. So some of that old equipment, it was run by a guy I will describe. I said he was trained, and I used to tease him about it. I said he was trained back when hieroglyphics were used for training in the facility, because he was older than dirt, and I loved the guy to death.
Yeah.
But he would run this piece of equipment with blue in. So he blew it in, he'd cut it to see a certain angle, and he knew these things because he'd been doing it for 45 years.
Yep.
And he would be blued in and make his cuts. Well, the newer stuff is run. You got to go put it on a CMM, and it's checking with a little ruby-tipped ball.
Yep.
That's measuring. It could measure in the millionths. And you got one guy over here with blue in, and there's a machine measured in the millions.
That feels good. That's nice. Yeah, that's a good one.
That's a good. The look of it is right.
That's a good cut.
It fits together, right? As long as they fit together, that's all that matters. They glued in together.
And back then, that is all that mattered.
Well, and it was still. I mean, we were still making product on the piece of equipment, so those design criteria still needed it. All it needed to do was these two fit together and didn't wear in certain ways.
Yep.
So again, the design criteria for what that equipment could handle, it didn't have super precision, but it cut to what you needed it to. Mm-hmm. So I think, again, as people challenge these and they go through these traps and they're understanding your newer stuff may have that precision level, But with that precision level is going to come a challenge for maintenance.
That's right.
Because you've got to make it hold that. I remember on our more expensive piece of equipment, we had a problem. We were running a very difficult part to run. It's basically you had to match all of these things within millions of each other. And they're not just one piece. I had to run 3 pieces, and they all had to have a tolerance. It's a tapered bore that had to match on there.
Right.
And we could not get the thing to run properly. Like there was just something going off in the piece of equipment. And we were troubleshooting for about a day operationally. And then we stopped it. We called up maintenance. We were like, you guys were here yesterday doing PMs. What did you guys do? And they're like, oh, shouldn't have affected it. We were just changing out filters. It was nothing big. And so we're like, changing out filters. So we went back and looked. Well, they had installed the wrong filter. And while the filters looked the same, it changed the flow rate just enough to cause a small, subtle vibration in the machine that messed up our tolerances.
Yep.
And it's like, that little small change when you're trying to measure in the millions makes a huge difference.
Didn't matter when you're just bluing it in, but now it matters.
Yeah,
right?
Suddenly it makes a big difference, that precision. So again, those practices that need to know for troubleshooting, that was always a challenge. I think especially as complexity of equipment increases, troubleshooting became a lot harder.
Yeah.
People with the old car versus a new car, you can kind of figure it out, right?
Yep. I can't open the hood now and understand. You look under there, and there's I recognize everything, but much of it I have no control over. I can't go in and make adjustments to anything. You don't pull spark packs out anymore like you did spark plugs and go play with those things. But on the flip side of that, you used to have to do that all the time and regap your spark plugs. You don't have to do that anymore. They're good for 60, 80, 100,000 miles. Actually, the spark packs are good for over 100,000 miles now. So those are the kinds of things that while before, it seemed like very easy to do the maintenance. You could do a spark gap, plug gap, very easy. You just don't have to do it anymore. So is that better or worse? It's neither. It's different. It's just different.
And so when we think about kind of, again, the maintenance perspective in here, and we're looking at troubleshooting, if I'm not troubleshooting spark packs because it's not a thing I've been conditioned to have to troubleshoot,
right?
How would I recognize that I need to now look at this?
Right. And it's hopefully you've got good maintenance procedures that talk about these things, and even having that's almost a disadvantage sometimes of not having newer people in, because the newer people have gone to the newer trade schools. They've gone to the vendor courses on this particular piece of equipment, whereas the bluing in guy hasn't had to go to these newer courses because he's just hasn't had to do that. So sometimes that experience can hold you back a little bit if you don't have the newer stuff in there. It's especially true on things like computer equipment. Oh my goodness, if you're not up to date on the newest and greatest software and hardware on your computer systems, your LAN systems and whatever else you got in your servers, you're behind. You're falling behind, and you rapidly fall behind without continuous improvement, without getting your people into the schools and get updated and take new training courses. And you can't rely on your 50 years of knowledge to now to keep up with this stuff. You have to have continuous training to keep up. So I think a lot of companies kind of miss that. Getting your people to training and getting them up to speed on the newest stuff is critical, or you just fall farther and farther behind.
Yeah, I remember at my facility, there was a big concern over getting people trained in that trade, because you don't have the same number of machinists or electricians or people with that knowledge base that you used to. What our facility did, and I thought it was a really good program, we got really cozy with the local trade school. So our plant did a lot to sponsor the local trade school, which is what you got to do to get cozy with them. But one of the things that we offered was a working internship. So we would get some of the students that were in that mechatronics class, and we would basically have them work 6 months, a year for us as a part of their schooling.
Right.
So when they got out of school, they already had a year. I was always told that a maintenance professional took about 7 years to actually be useful. Which, also is old maintenance guys saying that, so I never know how true. Yeah. But it definitely was like 3.
Sure.
Because you had to have enough experience with all the different pieces of equipment that don't break down all the time.
That's right.
That, hopefully you don't have the thing breaking down so much that people become really familiar.
Yeah.
And so by getting them in early, you became more connected with your trade school, so you had a better opportunity. You could see if they would work or not.
So that's from the trade school side. My grandson's in college right now, and at his college, the airlines, as an example, airlines are building them labs to do repair on jet engines. They're building the lab for the university, and they're not doing that out of the kindness of their heart. That's an expensive $40 million facility they're putting in there to do jet engine maintenance and put aircraft mechanics through the system. They're doing that because they need them, and they just need that kind of experience coming out of college, going into the summer internships and playing with jet engines, and they're able to quickly get useful people. As soon as they graduate, I've got a useful set of people here that are already partially trained up at least, and get them going. And it's the trade schools and are really partnering up with industry in more and more areas to get these kinds of things in place, because the trade school now tells the university, this is what I need. Well, that's what the university ought to be asking. What do you need out there, people? Because we're training people here now. What do you want me to train them on? Yeah. So it's a great partnership when you get those in place.
And I think when you look at, again, simplicity and complexity, as pieces of equipment get more complex, you could go out. You used to be able to go out and learn about cars from your dad. Right. You go out there, work on it with them. You start off by holding the flashlight wrong.
Yep.
But you learn over time.
That's right.
What to do and what not to, and what you need to look at and what you need to get done. Well, nowadays my kids, they're not going to know anything about, I have an electric car. They're not going to know anything about that.
That's right.
They're not doing any maintenance on it. They're going to, it turns on and we drive it.
On the other half of that, they don't have to know much to do on those things. So they don't have to know how to do any of that kind of maintenance.
But if they're going to be an engineer that's going to work on electric vehicles, where are they going to learn it?
That's
not
right.
learn it in your dad's garage
Not anymore.
You've got to have some level of connection. So industry and university, industry and technical schools have to get together to build that skill base, and that helps, again, handle that complexity, handle that difference as systems get, again, like I said, at our facility, we recognized we weren't going to be hiring just electricians anymore. You've got to have somebody that can do mechatronics, where they're going to be electricians and they're going to be working on these other things.
Yep.
You've got to have multiple skill sets.
There's very few in a manufacturing plant. There's very few times you don't have to have control systems built into whatever you're working on.
Yep.
I remember a buddy of mine. This is several years ago now, coming out of the Navy. He was on a new construction submarine, and he told me that they were starting up the seawater system. Very simple system, not a lot to it, but they're just testing. They're in building a brand new submarine, and they couldn't start the pump up. They had to wait for a software drop to come in so they could start the pump. And I was thinking to myself, software to start a pump. Back when I was in, there was no software to start a pump. You turn the switch, big old contactors, ka-chunk, 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 breaker shut, and there went the pump. No controllers and software running that stuff. So things have changed, and everything nowadays is connected to the systems as a system. It's not just an isolated piece of equipment anymore. Yeah, interesting.
So I think that gives some people a lot to think about and ponder. If you're looking for help with building that knowledge base for troubleshooting equipment that maybe you haven't been troubleshooting in a while, what's a great resource for people, Ken?
Yeah, so we've got for equipment troubleshooting, and especially focused on rotating equipment, but also lots of other equipment, is our Equifactor module, a lot of our taproot system, and it's got a great set of troubleshooting tools that are built into it. They're fully customizable, so you can go in there and play with it, and add your own stuff in there. So it's a really nice system to set up if you're looking to help some of those newer guys coming out for troubleshooting. Even some of your more experienced people who aren't familiar with a particular piece of equipment, we now have some troubleshooting tables to help them out. So, yeah.
All right. Well, To find out more, get more information, you can go below and find out more about Equifactor equipment troubleshooting and the article that we talked about from Justin. Make sure to subscribe and hit the notification bell so that when we go live on Thursdays, you're there to see firsthand and watch the podcast first. Look forward to hopefully seeing you at a course soon.
Yeah, absolutely.
And talking to you more.
All right. Thanks much.